Okay, it's been a while, but I've been playing around with mazes. So here is what I've done recently. So you see on the screen a couple of mazes, but as soon as I press enter, you'll see on the left-hand side the solved maze basically. So it starts off at the top left corner and goes to the bottom right-hand corner. So I've taken some QBasic code, uh, and I found it on Rosetta Code. So here's the link here if you want to check it out. Um, there's a bunch of different languages here that basically do the same thing. I took the QBasic code and modified it to Pascal. It'll work with Free Pascal and Turbo Pascal, and if you modify it enough, it'll work with Lazarus, but you need to put a little bit more effort in that. There's also Delphi code here, which I could have used, but it looked a little more complicated than I wanted to spend on it. The QBasic code seemed simpler. Let me just find it. Well, it was here. Let's see. Q. There we go, basic. So it says here it should work with QBasic as well, but you need to modify the width variable. Width is a reserved word in QBasic. But otherwise, this seemed to me the easiest code to follow and convert over. So I've extended this to make mazes that are around 40 columns, uh, but you can make it do less or you can make it more. I'm going to go through the code and just modify it a little bit, but basically I'm going to be using this to as a basis for creating some mazes to use in a future game, and I didn't want to do every maze by hand. I will take some of the better looking ones and modify them, but basically I wanted to use my pathfinding code to see if they're solvable. It does generate some mazes that are not solvable, and if I do this enough, we'll probably reach one. So each one that is solvable, you see the red path. Okay, so here's one that's not solvable, and that's because it doesn't reach the all the way at the end, at the bottom right-hand corner. There's something obstructing it. So if we try another one, this one's also not solvable, and this one is. Okay, let's take a look at the code. First, let me bring up Visual Studio Code. And this is the modified QBasic or QB64 code. Um, I hacked it up enough to make it work with me with my pathfinding code. Um, it's straightforward. If you follow the QBasic code, this is very similar. I did leave some unneeded code. We don't need this print maze here, but the rest of it is line by line the same as the QB64 version. And I've modified my pathfinding code. I've simplified it so it could be more general purpose. Now we have a one function that you specify the grid, starting point, end point, and it returns a list of the XY coordinates that it used to find the path. So this could be used in a number of things, but I'm using it more for simple games. And this, yeah, that's the QBasic code. And so this is the my main program here. It calls the MK maze unit, pathfind unit, and the my simple queuing unit. And here's where it all happens. Let's start right here. So we initialize the screen. We call it the make maze, and it stores everything in this array. We copy that array to our path grid array, which is slightly different, but we need to do that in order for it to create the path. And we draw the two grids here, and we perform the find target path. Again, we specify our grid, starting point, end point, and the f path variable here. It'll return a list of paths, and here we draw the path. So it executes this procedure here, and it basically plots every coordinate that we get back. Anyway, let's again run it so you can see, and I will make a slight modification to it afterwards so you can see how you can change it. So not solvable, solvable. Anyway, back to our code, and I'm going to reduce this down to just 21 columns. So there's two places we need to check. I'll save that, and so in our make maze and our path find, we need to change this. I could have a unit that defines just the constants there, but I'm a little lazy right now, so I'm just showing you the long way. And if we recompile this, I'll come back to our DOS box. I'm using this specific version of the DOS box because it works with the free Pascal Go 32 version. So if you try to run this in a let's say DOS box X, it doesn't work properly. It doesn't fully work properly in this DOS box also, but the command line version works good enough. So let's just compile it from there, and let's see what we get now. So we got slightly smaller, not solvable, not solvable, still, and I've made a mistake, and let's go back to our code. One thing I forgot to change is our target path. So we have a source, we start at 1, 1, and we our target path or end path is 1919. So let's recompile again. Okay, so now it's solvable again. I want to make one more change, and that's just to show you how to make the grid bigger. So in our plot procedure here, if we change this to these numbers to 10, I should probably put a constant. It'll make things easier, but again, lazy. So this is the long way. Save it. And if we compile again, no, we didn't compile. There we go. So not slightly bigger, but the second maze is off the screen. Let's show you how to fix that. So we have a second procedure that we draw that grid. I'm going to start at 25 here. Let's see if that fixes it. Okay. All right, so that's much better. So let's see. This is probably what I'm going to go with my little game. So 21 by 21, and It's much easier to follow with the maze being a little bigger. The maze is actually smaller, but the blocks are bigger. This one's not solvable. Okay, so let's finish with that. I will put the code on GitHub. It's not necessarily the cleanest code, but I don't plan to do anything further with this. This is just to test and learn from. So I'm going to leave it there. If you have any questions, drop me a note. I'll help you as much as I can, but usually I don't release this kind of code, but I figure it might be useful to somebody because I've always been looking for code like this and it's been hard to find. So that's why I'm releasing it. And thanks for watching.